Hey there fellow coders, this is Coding Cleverly. Today we're going to be talking about hash maps. Before creating the hash map, you want to have your LinkedList.java and Node.java inside of the same directory. So it's in my same directory over here, video 11, and over here you'll see that the two files exist. But before diving into the LinkedList.java file, I want to go into the Node.java file. Here we have a string key and a string value, and we also have a node next. So it's just a little bit modified as compared to our previous node files, but it's a little bit modified, it's not that much. Over here we have public node, string key, and string value. So we're assigning the key value pairs here. And then we have the next pointed to null, just like our basic constructor does. Now here we have a public void set next node, and we put a node inside of the parameter, and then we just set our next to that node. So we return this dot next to get the next node. And this is our special new method here. We're gonna have to set key value pairs. So to get the key and the value, and then we just assign them to the key value pairs inside here. For the LinkedList.java file, we have almost everything that's similar. We have a public node head. When we create a linked list, it's initially assigned as this dot head to null. So it's just an empty list. So we could add to head by using this method, key and value, to just add this inside of new head, just new node key value. So when we want to do new node, we just pass in key value, which calls this constructor here, and it does the work for us. And yeah, I'm not going into detail for this. If you want to watch the linked list video, I encourage you to check that video out first and then head on to this video. Now we have the add to head method. We also have the add to tail method, which adds to the tail. The remove head method removes the current head and then readjusts its pointers. The HashMap.java file. Now, what is a hash map? So you can see over here a simple array with 5 elements, and these indices will actually hold nodes. Before going into that much detail, I'm going to talk about what a hash map is. A hash map is constructed on top of an array using a unique indexing system. So this indexing system you can see over here. Now a hash map has a key value storage system that allows for quick assignment and lookup. If you want to get anything inside of this hash map, you could use their already built-in functions like retrieve and assign. So this famous term key value pairs will be used a lot in my video. So just remember that this is always going to be in a pair. Wherever there's a key, there's also going to be a value to it. So like for instance, if I say someone's name, like say Bob, and then the value would be, let's say, the place where it lives. So it could be the city where it lives. Like I say, Bob lives in Jersey City. A hash map is also a table that represents a relationship between a set of keys and a set of values. So you're not going to have just one key value pair. You're going to have a lot. So every index will have its own key value pair. And you'll see how this will map out. Now all of this is accomplished by using a hash function, which converts a key into an index into an underlying array. If I want to store the key Bob inside of this, what you would do is I would pass that into my hash function. So suppose there's a function that I passed the Bob inside. It's called the hash function. And what happens is that the hash function will convert the key into an index into the underlying array. So let's say it returns 3. And then we just pass it inside of this index. Now this might cause a problem, and that's the famous problem here. When a hash function returns the same index for 2 different keys, this is referred to as hash collision. Let's say we have Bill. Bill also will point, when we pass that into the hash function, it would return 3 and it will also point to 3. Now this thing is called the hash collision. When a hash function returns the same index for 2 different keys, it will be referred to as a hash collision. And the only way to get out of this problem is to adopt some kind of collision strategy. The 2 most important collision strategies you'll see are separate chaining and open addressing. Now separate chaining is if each array index will point to an independent data structure. And this means that every index will have its own data structure. So let's say I have a linked list here. I have a linked list here for my 1 index. For my 2 index, I also have a linked list. So every single index will have its own data structure. That is called separate chaining. And for open addressing, every collision initiates a probing sequence that would determine where to store the value for a given key. If we had Bill pointed to 3, we're actually not gonna go 3 anymore. We're actually gonna go and check if the 3 already has something inside. If it does, we just go 1 step forward, or how many steps we want. It depends on how we define our probing sequence. So it's customizable of how much steps you want to go forward. So every time you go forward and then check if it's empty or not. And if it's empty, then you could just point the thing inside of there. So let's say Bill will be pointing there. So that's open addressing. But the one that we're going to be focusing on this video is separate chaining. So let's go into the code and start writing our hash map, a data member. So it's called the linked list. Like I told you before, we're using the linked list. But we're using the array here. So we're saying array of linked lists. And we'll call this as HashMap. Now we're going to create a constructor here. And we're going to say public. We're going to say HashMap. Inside we're going to pass in the size of how much we want. And for this we'll say this dot HashMap is equal to new linked list. And we pass in the size here. So what happens right now in this line is a public linked list hash map. It's just an array of linked lists. So we want to put linked list inside of each. So for having something like this, this structure, suppose these circles are indicating linked list. We want to actually create a for loop and go all inside of each index and assign a linked list to each one of them. To do that, we could use a for loop. Int I is equal to 0. I is less than the size, I plus plus. And then we can initialize using this dot hash map, and we could get the index here by I, and we can say new link list. And we just pass in the constructor. And what happens here is that the constructor will be called, and every linked list would have just this dot head set to null. So what happens in this line is that every single index will now have a linked list, but it would be an empty linked list, and it would just have head set to null. And it won't have these 2 nodes. I just put these for the understanding. Suppose that every single index now contains a linked list that is empty. Now we could go to our special hash function. So public, it would return an int index. And we'll call this as hash. What we'll do is pass in the string key. And first of all, we want to actually get some kind of hash code. So we could have the int hash code. So we wanted the hash code to be assigned to 0. After that, we want to actually get every single letter from the key. Suppose the key is Bob. So let's say B-O-B. And we want to get every single ASCII value. So there could be different types of ways to create hash functions. But the process of what I'm going to do is that for every single letter inside of my key, I'm going to add that inside of my hash code. So we're going to get the ASCII value from here. So we're going to say Bob's ASCII value. So capital A, we know that's 65. So this is going to be 66. And then the O's ASCII value, and then the B, small b's ASCII value will be inside of the hash code. And you'll see how this will work. So I is less than the key dot length. And all right, so we need the function here. And then we have I plus plus. Now inside of this, we have the hash code. And we assign that with the hash code plus the character dot code point at, and then we have the key, which is the key that was passed in, and the index. So this is how CHARACTER. So what this line will do is that character dot code point at key and then I will actually point and get the ASCII value for every single letter. So in this case, it would get the 0th, meaning the first key letter, and it would assign. It would just add into the hash code. There will be our sum, and whenever we get our total sum, suppose let's get a hash code. In order to have the hash code inside of our array, we're gonna have to modulo this. So we're gonna say hash code, and we're gonna say modulo, and we're gonna get this dot HashMap dot length. So what would happen here is that the hash code will be moduloed by this dot HashMap dot length, which is the size of the hash map. And in our case, ours is 5 because it's 0 to 4. So suppose that the 5 one will be passed here, and the hash code, let's say, is some gigantic number. It's the sum of all the ASCII values inside of our example, which was Bob. It could be anything, but inside of our key. And then it would always, whenever you do this, it will always be within our hash map. So whenever we do this, we can guarantee that this will result in a hash code that would always be within the size of our hash map. And now we could just return hash code here and semicolon, and we're done. Now we're gonna create the assign method. So public, and we say void assign, and we're gonna pass in the string key, and we're also gonna pass in the string value. Now what we're gonna do here is that we're gonna first of all get the array index for where we want to assign this. So we could use the hash method that we already created. So we could call that by using this.hash, and we pass in the key. So we want to convert that just like how I explained in the explanation, and we want to pass that inside of the variable array index. This will give us the array index. So let's say we have this dot HashMap, and inside of this we actually put in the array index. Now we have the access to our linked list, so the value would be called list. So this is our linked list, and its variable is called list. So once we have the linked list, we're gonna have to apply some checks here. We're gonna first check if the head of the list, so we say list.head, we want to check if the head of the list is equal to null, if it's a fresh new list. If it is, we just want to add it, so we say list.add to head, and here we just pass in the key and value, which is already passed in for us. Cool autocomplete. And we could also return it after that. We have nothing else to do. We could just safely return from here. In case of linked list not being empty, we'd have to have a current node, and that would just point to the node which is at the head, and then we just loop it through just like our conventional things. Here, over here, we have to check in current not equal to null, and then what we could do is that we have to apply a check here and say if current dot key, and we say if that equals to the key here, right here. If they match, we say current dot set key value, and we'll just put in key value, and you can see this is actually coming from this one, set key value from here. So this current is actually a node. You can see over here in the node type, and it's pointing to the head, and checks if it's null, and if it's matching with the key, we just set the key value. We're just overriding. If it's already existing inside, we're just gonna override it, the key. If the list has a lot of elements, a lot of nodes, and there's no such key existing that has the same key which was passed in as the constructor, we could apply this condition if current.get next node, and then we could see if that is null. Current dot set next node, and we pass in new node, and we put in the key and the value pair. So that would do everything for that. And then if we are done with that, we just break it out. The current is equal to current dot get next node. So that was our assign method. Now, before going to the retrieve method, let me just summarize what I did over here in the assign. So we have the key value already here, and we want to add in something inside of our linked list. We want to add Bob and its place, let's say Jersey City. So the key value pair here would be Bob, which is the name, and then the value would be Jersey City, which is the name of the city where he lives. We passed in these two, and we got the array index by just getting the key hashed from our hash function, which was right here, which returned the array index. And if we wanted to locate that inside of our hash map, we could do array index, and we could get the linked list that was pointed over there. Any kind of linked list. Let's say we got this one. So this was where it was pointing to, and we got the linked list accessed here. So let's say it's 2. Now after that, if the list.head is equal to null, in this case, there's already some 2 existing here, right? So if it was null, it would just immediately add to head key value and it would just return. If it's not null, however, we have node current, and that would point to the head. If the current node not equal to null, we could just go into this iteration process and we'll just go next node all the time. And in the condition here, if that the current key is equal to the key that we passed in as the input parameter here, so we're just going to say current.set value key value. We're just going to put that, and whenever we go to the next portion, it's just going to check this condition here, which is the while loop, and if it's current not equal to null. So if it's like we assigned this, suppose we had just one thing and we assigned it, now it's not going to exist anymore, so it's just going to iterate until it finds null. So once it finds null, we'll just break it out. In other cases, it doesn't even exist inside of the linked list structure. Suppose the linked list structure has no node that has the same key as was which was for Bob. So we're just going to have to create something at the end. So let's say we're going to have to push it right here. To do all of this mechanism, what we have to do is we have to say current.get next node is equal to null. So we want to see if we are reaching the last element, and if it is, what we're going to do is that we're going to say current.set next node, and we're just going to push it inside. So suppose that it's adding to the end of the list right here. You can see this is added, and then once it's done, we just break it out. So that's our process of assigning. Now we're going to go for retrieving. Retrieve, retrieve. We're going to pass in the string key, and this would retrieve our value, whatever. For the retrieve function, we also have the key, and for that key, we want to retrieve something which was already existing inside of our hash map. To do this, we could say int array index is equal to this dot hash heap. We do the first process the same. Now we're gonna have to get this dot hash map. Now we have the array index, which was up there, but we want the head of it. So we can say the head node. For that, we want to add that into our node current, like that. After that, we're gonna go inside of a while loop, and we're gonna say, well, current not equal to null, a condition here, and we're gonna say current dot key is equal to key, and we're gonna return current dot value. We're also gonna have the iteration here, so we're gonna say current dot get next node. And once nothing happens here, if for instance there's nothing that is able to be retrieved, we'll just return null. So to summarize this, we created a retrieve method that actually has a return type of string, which will give us the value of our key. So string key, we pass in the hash function, which will return an array index that lies within the size of the hash map. To get the linked list head, we could do HashMap array index. This will give us the linked list. And to get the head node, we could just say dot head at the end, put that inside a current node, and then after that we check inside current not equal to null. If the current dot key is equal to the key that we passed in, we just return the value that was associated to it. If not, we just keep iterating until we go till null. And if for some reason if we don't find it, we'll just return null, indicating that it doesn't even exist inside of our hash map. So now we're going to create a hash map of people with the location where they live. So name and the location where they live. So we could say hash map people, create a new hash map, and we're gonna have to pass in the size. Suppose let's create a hash map of 15 size. This means that the people hash map will have the indices from 0 all the way to 14, meaning that it will have a 15 size. Instead of this 0 to 4, meaning that it has a 5 size, it will have a 15 size, which is pretty huge. So if we want to assign things like key value pairs, we can take assign, and it would actually take in the key and value. We both gave strings over here, so the key would be the person's name. So with the value, we're going to assign in New York. We're just going to have 2 more. And for the second one, we have Alice. She lives in Jersey City. And the last one we have is Bruno, who happens to live in Elizabeth. So these are just different cities from New Jersey. So now what we want to do is we want to call our retrieve method, and we want to see the output. So we could say, so the people hash map dot retrieve, and we pass in the key. So for instance, we wanted Bobby's location, and that should return Newark, the city in New Jersey. Now let's put 2 more. So this one would have Alice, and the last one would have Bruno. So there you have it, our complete main method. We're actually assigning Bobby, Newark, Alice, Jersey City, and Bruno, Elizabeth. So we're actually gonna get this Bobby, Alice, and Bruno. We're gonna put that in our hash function, which will convert this Bobby for every single letter. So B-O-B-B-Y, these are lowercase and these are uppercase. So for every single letter, so this is capital and this is lowercase. So every single letter has its own ASCII, and we're gonna add it all up. Once we aggregate the total, we're gonna modulo it with the size of the hash map, which will give us the array index, which will always be in the range of the hash map .java. So this would create class files, and the one that we need actually is Java, and we have a HashMap. So over here we could see for every single name we have its specified city location. So the first one being Bobby was living in Newark, Alice living in Jersey City, and Bruno was living in Elizabeth. Thank you so much for watching the video. Keep supporting the channel by subscribing and liking. Until then, peace out.